All right, today we're going to be looking at solving equations with rational functions. In these notes, we're going to get rid of denominators and then solve rational equations. What we're looking for is where two rational functions intersect. So our steps for solving, number one, we have to get rid of all of the denominators. Just like with basic equations, when we're solving multi-step equations, anytime we have a fraction, we like to get rid of those denominators. So we have two ways that we can do this. A, if you have one rational expression on each side, so you have a fraction equal to a fraction. This is something you've seen since middle school, where we cross multiply to solve. B, if you have more than one rational expression on each side, so let's say you have two fractions, or maybe you're adding and subtracting on one side and you're adding or subtracting on the other side, we need to find the least common denominator like we did for addition and subtraction. And then we're going to multiply the entire equation by that LCD. That's going to help us get rid of those fractions. Once we've done that, we're going to solve for x, and then we need to check for extraneous solutions. I always like to first look for an extraneous solution. Where is my equation undefined first? And that helps me when I get my answers. So let's look at this first one here. So here it says solve by cross multiplying. Again, we only do that if we see a fraction equal to a fraction. So before we start, what x values will make these functions undefined, meaning when will my denominator be equal to 0? So if we look at our first one here, we make our x minus 2 equal to 0. So that gives me a 2. Then we get our 2x minus 10 equal to 0. So when I'm solving for x here, I get x equals 5. So I know for sure that my x cannot be equal to 2 and it cannot be equal to 5, because that will give me a 0 in the denominator, which is not possible. So let's go ahead and cross multiply. So when we do this, take your time with it. Don't be rushed. I like to just write this down. What am I multiplying? I am multiplying 7 times 2x minus 10. And then we put equals 2. That's very, very important that you put that equal to sign, all right? And then we cross multiply here. So on this side, we're doing 11 times x minus 2. Now, because when we cross multiply, it doesn't matter if you start from the bottom or the top. You could have put the 11 times x minus 2 first, and that equal to the 7 times 2x minus 10. Personally, I like to go from top to bottom. All right, so now we're going to solve for x. Notice how we no longer have a fraction. So I'm going to distribute first. We get 14x minus 70 equal to 11x minus 22. And now we're going to put all our variables on one side. I'm going to move over my 11x. And then I'm going to add 70 to the other side because I want my x's on the left and my constants on the right. So 14 minus 11 is 3. So we have 3x equal to negative 22 plus 70, which is 48. Divide both sides by 3. 48 divided by 3 gives me 16. Notice how that 16 is not an extraneous solution. Therefore, it is a possible solution. All right, so now let's go ahead and look at this second example. It says before we start again, let's see where we are undefined. So if we make our x squared plus 4x equal to 0, factor out an x. It makes it easier to solve. That means x equals 0 and x equals negative 4, because each of our factors would be equal to 0. And on the other side, we have x plus 4, which we already have that. X equals negative 4, so we only need to do that once. All right, so let's go ahead and cross multiply. So I'm going to do 3 times x plus 4 equal to, and then I'm going to do 1 times x squared plus 4x. Don't need that 1. I could just write down x squared plus 4x. But again, for notes, I'll do more work than I usually have to. Let's go ahead and distribute 3x plus 12 is equal to x squared plus 4x. I'm going to move everything to the right side because I want a positive x squared. So I'm going to subtract 3x, and I'm going to subtract the 12. We get 0 equals x squared plus x minus 12. So when I factor this, I want factors of negative 12 that add up to 1. So I know I'm going to be using a positive 4 and a negative 3. So now when I equal each of my factors to 0, I get a negative 4 and a positive 3. Well, looking over at my zeros that make my equation undefined, I see that we have a matching one. X equals negative 4. That means this is not possible. That is an extraneous solution. So the only possible solution for this rational equation is x equals 3. All right. Let's go ahead and look at what happens when we have more than one fraction on each side. So we're going to solve by using the LCD. We're going to start off really simple with something that we've seen in Algebra 1 and in the beginning of Algebra 2. Again, when we are solving, we do not like to have fractions, so we got to get rid of them. Since we have denominators that are all different, we need to find the LCD for these three numbers. So we're looking at 2, and I'm going to write down all my multiples of 2, 2, 4, 6, 8, 10, 12, 14. I'm going to stop right there. Then I look at my 3. We have 3, 6, 9, 12, 15, 18. And then 4, I have 4, 8, 12. And I'm going to stop right there because this is the first time that this 12 comes out in all three of these columns. That is your LCD. So what we're going to be doing is we're going to multiply this entire equation by that LCD. Now, if you want to, you can go and multiply each one. You can actually write it out. Do 12 times 1/2 x plus 12 times 5 is equal to 12 times 2/3 x plus 12 times 3/4. This is pretty much what we're doing. We are multiplying every term in this equation by that least common denominator. And what that's going to allow us to do is to get rid of our fractions. So 12 times 1/2 x is 6x plus 12 times 5 is 60. 12 times 2/3 is 8, so 8x. And then 12 times 3/4 is 9. And now we have an equation with no fractions. And now we're just going to solve for x. I'm going to move my 6x to this other side, which means I'm going to move my 9 to this other side. And we're left with 51 equal to, oh, I wrote this number wrong. This is a negative, which means this is a negative, which means we're going to actually add 6 to the side. So we have 14x. And then divide both sides by 14. We get x equals 51 over 14. Now, the reason that we did not have to do our extraneous solutions here is because we did not have an x in the denominator. Now, looking at this next one, you can see we have some x's in the denominator. So we would actually have to figure out where we're undefined. So we would be undefined at x equals 0. So to find the LCD, just like we did with our addition and subtraction, because we have, especially now because we have variables in the denominator, we're going to go from left to right. So the first factor is x. I'm going to write that down for my LCD. And then we have a 2, so that's another factor of my LCD. And then we have an x again, which I already have written down. So my LCD is 2x. So I'm going to multiply this whole equation by 2x. So what I'm doing here is I'm doing 2x times 3 over x minus 2x times 1/2 equal to 2x times 12 over x. Now what this does is it gets rid of my x's here. Here, half of 2 is 1, so that gets rid of that 2 in the denominator. And here it gets rid of the x in the denominator. So when I multiply, 2 times 3 is 6, minus x times 1 is just 1x. That equals to 2 times 12, which is 24. So now, subtract 6 to the other side, we get negative x is equal to 18, which means x is equal to negative 18. And if we look at our undefined, they are not the same, so x equals negative 18 is the answer to this rational equation. All right, so now we have a fraction or rational expressions with binomials in the denominator. So again, let's go ahead and find our LCD. Actually, let's find where we're undefined first. So undefined at x plus 1 equal to 0. So we're undefined at x equals negative 1. All right, so let's find our LCD starting from left to right. Since we're already factored, I don't have to factor anything. So one of my least common denominators is going to be x plus 1. There's nothing under the 4. And then we have another x plus 1. We already wrote it down. So my LCD is x plus 1. I like to put these in parentheses. It makes sure that we multiply correctly and things like that. So I'm going to multiply everything by x plus 1. So that means I'm doing x plus 1 times 5x over x plus 1 equal to x plus 1 times 4 minus x plus 1 times 5 over x plus 1. So I'm going to go through, I'm going to cancel everything out that I can. So the x plus 1s cancel out, and these x plus 1s cancel out. So what I'm left with is the 5x here equal to, we're going to distribute that 4, so we're left with 4x plus 4. And here, I'm just going to distribute the negative, minus 5. So now we're going to solve for x. I'm going to subtract this 4x to this side and combine like terms here. So we're left with x equals negative 1. But I look over here where it's undefined, they're the same. So this means there is no solution. It's really important that you identify where it's undefined so we can figure out if we have any extraneous solutions. And in this case, because it's the only possible solution, there is no solution at the end. It is not possible to have x equals negative 1. All right, let's look at here. We have 1 minus 8 over x minus 5 equal to 3x. So let's figure out where we're undefined first. We have x minus 5 equal to 0. So we're undefined at x equals 5. And we're also undefined at x equals 0 because those are my denominators. So for my LCD, again, make sure that we're in factored form. We are perfectly factored so we can get our LCDs right away. We have an x minus 5. I like to put that in parentheses. And we have an x. So my LCD is x times x minus 5. So this is what we're multiplying everything by. All right, so I'm going to write this down. We have 1 times x minus 5 minus, and then we have x times x minus 5 times 8 over x minus 5. And this equals to x times x minus 5 times 3 over x. So now I'm going to go through and start canceling things out. There's nothing to cancel out with this first term. If I just multiply that one, we don't even need it. Cancel that one out. So I'm going to distribute here. So we're left with x squared minus 5x. On this side here, our x minus 5's cancel out. I'm left with an x and an 8. And then we have a negative. So this is negative 8x. And this equals 2. And here the x's are going to cancel out. So I'm just going to distribute the 3. We have 3x minus 15. So now I'm going to start combining and moving things over. Since I have a quadratic and there's the only x squared, I'm going to move everything to the right, to the left. So minus 3x plus 15. So we're left with x squared, 5, and negative 5 and negative 3 is negative 8, and negative 8 is negative 16x plus 15. So we have a quadratic. Let's look for some factors of 15 that add up to negative 16. So we'll use negative 15 and negative 1. So when I factor that, I get x minus 15 times x minus 1 is equal to 0. So we have x equals 15 and x equals 1. So if we look at our undefined, we can see that they are not the same. So both of these are possible solutions. All right, now we're going to look at 3x minus 2 divided by x minus 2 is equal to 6 divided by x squared plus minus 4 plus 1. So here we can tell that we're not completely factored in our denominator. This is going to be a difference of squares. So this is x plus 2, x minus 2 in the denominator. Cross that out. And now when I get where I'm undefined, we have an x minus 2, which is going to be x equals 2. And we have an x plus 2, which will be at negative 2. So my LCD, we have an x minus 2. We have an x plus 2. And we have an x minus 2. I already wrote that down, so I'm done with my LCD. So I'm going to multiply everything by that LCD. So we have x minus 2 times x plus 2 times 3x minus 2 over x minus 2. I don't need this parenthesis. And that equals 2. And then we have x minus 2, x plus 2 times 6 over x plus 2, x minus 2. I like the factored form, it makes it easier to cancel. Plus 1 times x minus 2, x plus 2. All right, so let's start canceling things out. The x minus 2's are going to cancel. So I'm going to do my FOIL method right away. X times 3x is 3x squared. X times negative 2 is negative 2x. 2 times 3x is 6x. 2 times negative 2 is negative 4. Over here on this side, these both denominators cancel out. We're left with just the 6. And then over here, when I multiply this again came from my difference of squares, which is just x squared minus 4. So now we're going to move everything over to the left. So I'm going to subtract the x squared. I'm going to subtract the 6. And I'm going to add that 4. Put it right here on top. So it's going to give me 0 on this side. Here I'm going to have 2x squared. Negative 2x plus 6x is 4x. And here the 4's are going to cancel. I'm left with just negative 6. All right, so to solve here, I can see that they're all divisible by 2. So if I divide both sides by 2, that leaves me with x squared plus 2x minus 3 equal to 0. And now I'm going to look for factors of negative 3 that add up to 2. So we're going to use 3 and negative 1. So what that leaves me with here is x plus 3 and x minus 1. and that equals to 0. So our x equals -3, our x equals 1. Looking at where we're undefined, I see that these are both going to work out. All right, the last one we're going to look at here, let's go ahead and factor that denominator. So this becomes x plus 3, x minus 3, because it's a difference of squares. Let's go ahead and figure out where we are undefined. We have an x minus 3, so we're going to be undefined at 3, and we have x plus 3s. So we're also undefined at -3. All right, so that lets me know what I'm going to be multiplying by. Let's figure out what my LCD is. We have an x minus 3. We have an x plus 3. We have an x minus 3 we already have written down, and we have an x plus 3 we already have that written down. So I'm going to multiply everything by that LCD. So x minus 3 times x plus 3 times 6 over x minus 3 is equal to x minus 3 x plus 3 times 8x squared over x plus 3 x minus 3 minus x minus 3 times x plus 3 times 4x over x plus 3. Now, of course, there are shortcuts where you don't have to write all of this out, all of these, but that comes with a lot of practice with these. I don't recommend going right off the bat with any kind of shortcut. If you start to feel comfortable with multiplying your LCD, and then you want to come in and ask me about that shortcut, I'm more than welcome to kind of help you out there. But before you get a shortcut, you need to be comfortable with this type of multiplication here. So we're going to go through, start canceling out our common denominator. Here we have x minus 3, x minus 3. So I'm going to distribute right away. 6 times x and 6 times 3 is 6x plus 18. And that equals to, here, both of these are going to cancel out. We're left with just 8x squared. And over here, our x plus 3s are going to cancel out. So I like to distribute this negative first. That's going to leave me with a negative x plus 3. And so now when I distribute times that 4x, it becomes a lot easier to not have to worry about that negative. You can also distribute the negative to the 4x if you wanted to. So you could do something like this, distribute that negative over here. And now when you distribute, just make sure you distribute that negative 4x. So that becomes a negative 4x squared, and this becomes a positive 12x. So now we have a much nicer equation that we can solve. We can combine our like terms here, and then let's go ahead and move everything over. Since my x squares are going to be on the right-hand side, let's just move everything over to the right. So a negative 6x and a negative 18. So this leaves me with 0 equal to 4x squared minus 6x minus 18. All right, so I can see that we can divide everything by 2 here. So I'm going to rewrite this as 0 equals 2x squared minus 3x minus 9. And now this is going to become a little bit easier to factor. We're going to deal with smaller numbers. So I want factors of negative 18 that add up to negative 3. So what am I going to use here? 6, negative 6, and positive 3. So when I factor this, I'm going to have to factor by grouping. So when I factor out my GCF, I'm going to be factoring out 2x on this with this group. In my second group, I'm going to factor out a 3. So I'm going to put a plus 3 right away. And then when I factor everything out, it's an x minus 3. Again, I'm doing it this shortcut just because I don't have space to do everything else. So when I equal each of my factors to 0, to x plus 3 equal to 0, and x minus 3 equal to 0, we get a negative 3 halves and a positive 3. But as you can see, that's one of my undefines. So this is not a possible solution. The only possible answer is negative 3 halves. So we will be looking at more examples together in class. Hopefully you've copied everything.